Welcome to part 6 of our Working with Strings video series. And we're looking at regular expressions. I want to continue looking at some expressions that are useful in that they indicate how much repetition is needed for a match to be detected. So I'm going to start off with a list of numbers. I'm going to call it R numbers, and this is just going to be one string of numbers here. And then I'm going to show you some examples with the repetition characters. So the first one we're going to look at is this question mark. So what that question mark means, and up here I've got a little bit of cliff notes for you. The question mark means, do you have 0 or 1 matches of this character? So if you look at this string that we put in here, we have a 0, so we're trying to match a 0, and that can be followed by either another 0 or not. In essence, it makes that second 0 optional in order to find a match. So when I click on this, it matches this 0. Why? Because that second 0 was optional, because it's looking for 0 or 1 matches of that second 0. Now look at here what else is in our string. We have a bunch of 1s. So this is saying find a 1, and it doesn't matter whether or not there's another 1, but if there is one, find it. And so here we go, and it found it. Now you might wonder, what about the ones after that? Well, there are other regular expressions we'd have to add to ask us to repeat this. So when you give a single regular expression command, it's going to find it once. But then you can add some commands and say repeat these sequences. So that's why we're only finding this first one here. Now, the next one is a plus sign, and that's used for 1 or more matches. So now we're no longer talking about optional. So notice here, we're counting 1, 2, 3, 4 2s, followed by at least 1 2, because it's 1 or more matches. So when I run this, I don't find any of these. Why? Because it was asking for 4 2s followed by at least 1 more 2. And so this doesn't match the pattern. On the other hand, if we use an asterisk stands for 0 or more matches. So now here I have 1, 2, 3, 4 2s, and then it's asking us for this character to find 0 or more of them. Well, now you should anticipate what's going to happen when I run this. It does find those 4 2s because it's 4 2s followed by 0 or more 2s. So 0 2s means none. So it's just showing you these 4 2s. Now you might think, when would I ever use this? Well, here's a really practical example right off the bat. Suppose that we want to account for both the American and British spelling of color. So here is the American spelling, C-O-L-O-R. Here's the British spelling, C-O-L-O-U-R. And here's neither. So I'm looking in my strings, and I'm looking in my strings to see if I can find the word color. And by putting U followed by a question mark, that means the U may or may not appear. It's optional. It either appears 0 times or it appears once. So now when I run this, I find the American spelling of color and the British spelling of color, and of course the one that is not color is ignored. We can use parentheses to help define our pattern. So here I have a concatenation of 3 strings, orange, apple, and banana. And here I'm going to search through my strings to see if I can find BA followed by, and the parentheses now lumps together this NA. And so the plus sign, remember, means one or more matches. So I'm looking for BA followed by at least one NA, but more of them is okay. So when we run this, we get the entire word banana because we have BA and then NA appears twice. And so we get this whole thing. You can specify the exact number of matches. Use the curly braces with N in the middle. N is actually a digit for exactly N matches. And then use N or a digit with a comma for that or more matches. Or you can use a digit, comma, another digit for between N and M matches. In the environment window, there is our pattern. So what this is looking for now is, can we find exactly 3 2s in this? And we did find exactly 3 2s right here. It doesn't matter that there's another 2 following it. We're looking for 3 2s in a row. Can we find 4 2s in a row? Yes, we can. Can we find 5 2s in a row? No, we cannot. We only have 4. Can we find between 3 and 4 2s? Yes, we can. There's 4 of them. Can we find between 4 and 5 2s? Yes, we can. There's 4 of them. Can we find between 5 and 6 2s? No, we can't. There's only 4 in a row. Knowing regular expressions is a foundation for using string tools in the tidyverse. There are many more. They can be powerful. So keep this in mind if you need to detect a pattern that we haven't covered. And you can always search for more regular expressions, including ones that people have already developed for you. Now it's time to learn about the string tools we can use with these regular expressions to do useful things. We can use string detect to see if we can find a pattern match in a character vector. So let's remember what our student names are. So here's our student names: Edward, Alice, Manuel, Carl, Richard, Felicia. And now let's see if we can string detect IC, and look at what we get. We get a logical. So we're looking, any IC in the first name? Nope. In the second? Yep, Alice has it. The third? Nope. Fourth? Nope. Fifth? Yes, Richard has it. And so does Felicia. Remember that the caret meant it has to come at the beginning. So let's do that. String detect. And the only one that has it at the beginning is Richard. Remember, when we have brackets, we're looking for any of the characters in the brackets. And so what do we have? We have no E or I. Well, you might say Edward has an E, but this is a lowercase e we're looking for. So no lowercase e or I, but Alice has it, Manuel has it, Carl does not, Richard does, and Felicia does. This next one, line 279, asks us if we have any names that do not have capital C, A, R, or L. So of course, when we run this one, we're going to have true for everything except Carl, which has all of those, capital C, A, R, or L. Remember that period can be any character. So can we find any character followed by an E in our names? Well, let's see. We have Alice, C followed by E. Manuel, U followed by E. Not Carl, not Richard. Felicia has a capital F followed by E. Notice that there was a capital E in Edward, but not a character followed by a lowercase e. The vertical line is an OR. So this asks us, can we find an AR or an IC? So when we run this one, we have an AR for Richard, an IC for Alice, neither of those for Manuel, an AR for Carl, an AR for Richard, and an IC for Felicia. So everything except manual was detected. Sometimes regular expressions can be made easier by just using R functions. Here's a regular expression for finding words with no vowels. We're not even going to talk about what all this means, but this finds words with no vowels, and we only have one of those, and that's shy. That's the only word there with no vowels. So that regular expression worked. But here it is again in simpler form, just using R operators. We actually still are using a reg expression. That's the stuff here in brackets, but it's a much simpler regular expression. And that is, can we find anything with an A, E, I, O, or U? And notice the exclamation point at the beginning? That's the R operator we're using now. And that operator says not. So we're going to look for the things with a vowel in it, and then we're going to take the opposite of that, and we get the exact same thing in a much easier fashion. We can use string detect as an index to pull out words. That's pretty cool. So here I'm going to pull out some words and use that exact same function I used before to pull out every word that doesn't have a vowel in it. I didn't notice before that myths was at the end and it was showing up as true each time. I said just shy. I didn't notice that other true. So you probably did. And now we see it all together here in shy myths. We can use the string subset function to subset out words. Here we are using a more complicated regular expression and substituting out. And here comes shy myths. That example makes it look difficult because the regular expressions is difficult, but here's an easier to see example. I want all the names that end with L, so I could do it this way, but I also could use string subset, student names, and then L and the $ means ends with, and that pulls out the same thing. So there's more difficult ways to do it, and there's easier ways to do it.